Hi, welcome back to Shotoku Tech. I had fun playing with this solar-powered air conditioner. Basically, it's a desktop evaporative cooler attached to a rechargeable battery pack that has its own solar panel built in, and I even added another external solar panel that's intended to power an outdoor security camera. Well, it cooled me off for about 3 hours, and then once the battery ran down all the way, it took 3 days to charge it again. So that didn't seem like a very effective experiment in solar power. Yeah, I don't want to put these out in the direct sunlight in Arizona. The sun will just tear that battery apart. I'm sure the LiPo battery inside that thing would probably blow up in the plus 100 degree heat. You'd probably get that thing heated up to 120 degrees out in the sun. So I'm interested in playing with bigger solar panels and bigger batteries. And I thought it would be a cool idea to have a TTGO T-Display voltmeter to monitor the output of the solar panels. So when you consider on the TTGO T-Display, the ADC pins will only accept up to 3.3 volts. So we need to divide whatever voltage we're measuring. We're using this voltage divider calculator. So our maximum output voltage should be 3.3 volts. That's right here, and we're going to connect that to the ADC pin on the TTGO T-Display. Now I have a 10K ohm resistor essentially grounding that pin right here in the diagram, and then the inline resistor is 100K ohms. And that gives us a source voltage of 36.3. Essentially, this 36.3 becomes a multiplier in our Arduino code here. We're going to multiply the reading of the ADC pin by that 36.3. Yeah, the TTGO T-Display has several ADC pins. Some of them might be in use for other devices. It looks like they work with the touch screen. So if you were to activate the touch screen, you might not be able to use some of these ADC pins, for example. So I'm going to use pin 32, which is ADC 4. So in the code, I'm defining analog pin 32 as pin 32, and I'm initiating a variable ADC 4. The rest of the code is just the minimum you need to display something on the TTGO T-Display. And then here we set the value of ADC 4 to the analog read of analog pin 32. Next, we have to multiply that by that 36.3. So we'll put that value here. And finally, you divide that by the resolution of the ADC pin, or 4095. Let's go ahead and send the code to the TTGO T-Display. Alright, I'm going to hook up the alligator clips to this battery. These are two 18650 LiPo batteries. They've just been recently charged, so we should get somewhere close to 8 volts. Whoa, that looks a little low. 6.67, 6.68. Let's put our voltmeter on here and see what the real reading should be. Yeah, 7.95. We're almost 1.5 volts off. I think we need to adjust our resolution. We're going to go back to that voltage calculator and change the value of some of the resistors, because you got to consider this 8 volts here isn't even a quarter of that resolution that we set with the 36.3 volts as the maximum. The other thing with these ADC pins, as you get closer to the bottom or closer to the top, those readings start to skew. So we want to cut this number down. We're going to have to go back into the voltage divider calculator and see what we can do. First of all, I'm going to clear the voltage source because we want to calculate a new one. I'm going to go ahead and double this resistance here to 20K ohms on the shunt resistor going to ground. Oh, that comes to 19.8. We just about cut our resolution in half there. We'll plug that here into the Arduino code. 19.8. So we're going to go ahead and add another 10K ohm resistor here. I'm just going to flip this out to a blank pad on the breadboard there. And then we're going to attach another 10K ohm resistor in series with that one, going back to the ground pin. There we go. And we attach our ground alligator clip. Yeah, you can adjust the resolution on your voltmeter just in the same way so that you can get a more accurate reading depending on what range of voltage you're examining. Here, that 19.8 is more than enough to cover these 12-volt solar panels. So we've updated our code, 19.8. Let's go ahead and upload it. And we're going to go ahead and attach our alligator clips to the battery here again. Well, that's a lot better, 7.34, 7.35 volts. We're about a half volt off. Depending on what other resistors I have on hand, I can probably go back and forth to the voltage divider calculator and wire this a little differently and get it more accurate. It's an interesting exercise though. Next, I'm going to also calculate the current, and I want to send this to the Cubitro IoT cloud so we can monitor our solar panels from the internet. So you're going to want to stay tuned. Look for all the links in the description down below. Give this video a like and comment below on what experience you've had with solar panels. And please, before you go watch more of my TTGO T-Display videos, go ahead and click on subscribe. Thank you very much.